Welcome to 3.1 Arithmetic Sequences and Linear Equations. Alright, so here's our example. Consider the recursively defined arithmetic sequence u sub 0 equals 2 and u sub n equals u sub n minus 1 plus 6, where n is greater than or equal to 1. That just remember that just means we're going up. We're going from 0 to 1 to 2 to 3 to 4 to 5 to 6. We're not going to go backwards because sometimes that wouldn't make sense. Alright, so you have seen this before. We've started this in a previous chapter. And so you should be familiar with what this is and how to generate the next several terms in the sequence. Alright, but now what we're going to try and do is we're going to try and connect what we've done before in Algebra 2, arithmetic sequences, with things we've done in Algebra 1, which are linear equations. Now some of you might have already been able to say, I think I know what an equation is if I can say, I'm going to keep on adding 6 and then adding 6 and then adding 6. Alright, so we're going to try and write an explicit formula. So if we see that, we're going to just define explicit formula right here. Okay, so first we have to say an explicit formula. What is that? That is just much like an equation, all right? An explicit formula gives a direct equation between two discrete quantities. Alright, so what do we mean when we say discrete? Well, what I'm talking about discrete is numbers, things that are not continuous. So if we're talking about something like this is going to be discrete because we're going to say u sub 0, and then u sub 1, then u sub 2, then u sub 3, then u sub 4, u sub 5. So we're always going to have this number, the sub number, go up by 1. Right? So that means we're going to kind of count. There's going to be breaks in them, okay? Where discrete would be kind of like a dot, and then a dot, and then a dot, and then a dot, and then a dot, like that. Where a continuous would just be a line. Okay, so this would be like a discrete graph. This could be a continuous graph. So we're talking about discrete, meaning we could talk about just going up by 1, 2, 3, 4, 5, 6. Okay, so an explicit formula gives a direct equation between two discrete quantities. So that means where are we going to start and how much do we change? If that sounds familiar to you because you've learned it in Algebra 1, that's really good. So where do we start? Okay, so for part A, we're going to say where do we start? Well, we start at 2. And what are we going up by? How much do we change? We're changing by 6 every time, right? Okay, so when we say change, what we can really think of here is you can think of change as the slope of a linear equation. And you can think of the start as the y-intercept. Alright, so if we wanted to write some sort of equation for this, let's do it now. So even before we do that, let's just start off by saying u sub 0 equals 2. U sub 1 is going to equal 2 plus 6. That's a 6. There we go. And we're going to say u sub 2 equals 2 plus 6 plus 6, right? Because we just take the previous term and add 6. U sub 3 is going to equal 2 plus 6 plus 6 plus 6. And u sub 4 is going to equal 2 plus 6 plus 6 plus 6 plus 6. Alright, so if you notice, how many times did I add 6? Well, I added it once, which is the same as there. I added it twice, which is the same as here. I added it 3 times, which is the same as here. I added it 4 times, which is the same as that 4, right? So let me just move this up a little bit so that way I've got some more room. Okay, so that means if I'm going to say I'm going to start at 2, and this is 1 6 and 2 6s and 3 6s and 4 6s, notice that the number of 6s that I have is the same number as this u. So I could really say, that could mean that I could say u sub n is going to equal 2 plus the number of 6s that I have, so 6 times n. Right? So there would be an explicit formula right there. U sub n, that number is going to equal 2 plus 6 times the number of the n that I have. And there would be our explicit formula. Alright, so there is part A. So now we can use this explicit formula for part B. Let's use this explicit formula to find u sub 22. Alright, so I'm just going to go through and find that u sub 22. I'm just going to move this right over here so I kind of got like a clean page. Alright, so I want to find u sub 22. So we're going to say that's going to be the same as 2 plus 6 times 22, right? Alright, so 6 times 20 is going to be 120. And 6 times 2 is going to give me 12. So I've got 120 plus 12 plus 2 is going to equal u sub 22. So that's going to equal 122, 132, 134. So we can say u sub 22 equals not 14. Let's try that again. It's going to be u sub 22 equals 134. All right. So there is part B, right? I'll just make sure I label that part B. All right, then let's go back and look at part C here. Part C says find the value of n so that u sub n equals 86. All right, so now we're going to go right back up here and let's do part C. So part C says u sub n equals 86. So I'm going to put 86 in for this part right here. So we get 86 is going to equal 2 plus 6n. And now a lot of you should be able to say, oh, I think I know what to do. I've been solving equations for a while. Subtract 2 from both sides, subtract 2, and we should end up with 84 equals 6n. And you say, well, if I want to find out what n is, I got to divide by 6, divide by 6. Okay. And, well, how can we figure out how many times does 6 go into 84? Well, I know 6 goes into, we could say 84 is going to be 60 plus 24 divided by 6, and that equals n. And 6 goes into 60 10 times, 6 goes into 24 4 times, so we can say this would be 14. Alright, 84 divided by 6 is 14, so we can say 14 equals n, which I believe is what they were looking for, right? Yep, find the value of n so that u sub n equals 86. We got that. We're all good. All right, so if you look at this and say, you know what, this looks like a linear equation. So I could say, when we go back here and we say, let's look at the start, the change, right? We're talking about y-intercept and slope. Now, do we actually have those things? Because really on our graph, if we were to graph this, it would just be dots in a linear form, right? We don't have all of them filled in. We don't have u sub 1.763. We could plug a value in and find some things, but that's a little bit weird here. But we're going to try and make the connection between these arithmetic sequences and linear equations. All right, there you go. There's example A.